Hello everybody, I am Matteo Andreottola, I am a structural engineer. I am of course as well part of Rothoblaas and in particular Roto School. What is Roto School first of all? Roto School is a part of Rothoblaas taking care of the formation of internal people but also external people. So we make courses and seminars every year for people interested in the timber sector basically. We have, for example, this year almost 120 courses around the world internationally in 7 different languages. And we decided as well to do these video lessons. These are for us very important. We'll have 9 video lessons this year, free of charge for everybody, because we think that timber is a great material to work with, has some great potential and characteristics, structural characteristics and also beauty, of course. But it is a material that if you want to use, you have to design in the right way, just to avoid issues of durability, to have the right connections in your buildings, and so on and so forth. So we placed 9 video lessons about the 9 hottest topics we think this year, and let's see how it goes. So first of all, I wanted as well to introduce a little bit what Rothoblaas is. Rothoblaas is a company based in the north of Italy. In fact, I'm speaking to you at the moment from Cortaccia, which is a little town from in between Trento and Bolzano, in the middle of the Dolomites, very close to Lake Garda, if you're not from Italy. So a very beautiful part of Italy. You can see as well from the image here where all of our subsidiaries are located all over the world, because we are actually working all over the world, close to where you are. We have 6 main lines, and these are the screws, for example, screws for wood, the plates, the tools, the soundproofing, the fall protection and safety, the tapes, sealant, and membranes for the airtightness and waterproofing. This is why we have an alpine heart but an international spirit, because we are located right in the middle of the Dolomites, but we are as well present and located all over the world with our subsidiaries. As you can see here, we are more than 400 workers in Rothoblaas at the moment. Actually, we are almost 500 as we speak, because we keep on growing and growing. And if as you can see here, but we're going to discuss more in detail also in the video lessons, also this particular mass timber structure here, we just recently finished the construction of this massive and very nice automatic mass timber warehouse that we have here in our headquarters of Rothoblaas. And this will, and actually has already doubled the existing warehouse space that we have in Rothoblaas. So for us, it's practice what you preach. We preach with our Roto schools around the world to use timber, and also for our own project, we use timber. The use of wood and of timber structure, of course, for us is very important for, as you all know, a sustainability point of view, very, very important. And this is why we preach also the use of this kind of material, structural material in this sense. But of course, as you all know, timber is a material that a lot of people are passionate about, and myself, I'm the first one to be passionate about it. And second of all, it has a lot of very, very good structural characteristics that we'll see throughout the video lessons. And this is why a lot of people love timber, not only because of its beauty, but also because of sustainability and great performance, really. What are these video lessons that we're going to do this year? There are 9 of them, actually. We start with the potential of CLT and mass timber, actually. Then we'll go for durability of timber structure and corrosion resistance for outdoor solutions, waterproofing and airtightness of timber structures, the acoustic in timber constructions, the fire design in timber structures, the seismic design, the composite structure or hybrid structure, a very hot topic nowadays to optimize the use of timber, the innovative connections for timber structures, and last but not least, the installation of full arrest system. Thank you very much, and thank you for your attention. Hello everybody, and welcome to the webinar of today. Today we are going to talk about a real important part of the timber constructions, which are the mass timber construction. In particular, we are going to talk about CLT structures. I present myself. I am Matteo Andreottola. I work for Roto School, but of course at the same time I am a structural engineer, and I've worked with timber structure for all my life. First in the light timber frame structures, and then in CLT structures. Now I work, of course, for Rothoblaas, and in particular for Roto School. So let's jump straight into the presentation of today. Let's go and see what we're going to discuss and talk about. We'll start seeing the production facilities of CLT. We'll start to know better how the material works. We'll study the advantages of this very nice material, and we'll see some of the characteristics of the timber material, in particular the reuse at the end of life, which is a very updated and hot topic, because of course you can reuse it quite easily, and the anti-seismic, the seismic behavior of this material, and the fire resistance. So we'll see a little bit an introduction to the mass timber in general. So first of all, as an introduction, you see where the most producers are located around the world. You see in the blue dots that you can see here, for example, these are the CLT producers around the world. In the little red dots that you see in the map are the subsidiaries of Rothoblaas. You see, of course, where I'm talking to you at the moment, right here in the north of Italy. That's where the headquarters of Rothoblaas is. And of course, as you can see in the map, all of the subsidiaries of Rothoblaas are located very, very close to the CLT producers. That, of course, makes sense for both the producers and Rothoblaas, because we work together a lot. So you see from the map as well that one of the most important places where actually was where the CLT was invented is the Austria, north of Italy, Germany, Slovenia, all of the region that I'm pointing to you right now. So this is where a lot of know-how is located worldwide. You see from this map here that, and this is really the first advantage that we will study together today, is that timber structure are very lightweight. This will come very, very much handy for the seismic actions, and we'll see it throughout the presentations, but in particular, it is very, very important because lightweight material means that you can move it around and transport it quite easily. In fact, you see here all of the main directories of export and import, of course, of this material. It's very common nowadays that we design and produce maybe timber structure here in the north of Italy, for example, and we export it from the US to the USA or to Australia or in very faraway countries. This is something that you can easily do with timber. You just place the panels into a container, ship it, and you can install it on the other side of the world. Another very important thing is the one that you see in the slide right here. So you see in percentage, of course, what is the growth of use of every construction material. You see that timber, which is the red one, has increased so much after 2020. So it is a material that is more and more common, and of course studying it and know how to build with it is a great advantage, since we are planning to have still another increase in the following years. Of course, as well, other construction materials have grown a lot. Like steel, for example, concrete, it's still growing, not so much, not exponentially like the others are, but still, of course, since a lot of the foundation, even for timber buildings and steel constructions, are in concrete, it makes sense that all of them are actually following the same path, growing. Another very good advantage that you have with timber in general, not only of course with mass timber in particular, it's the possibility to prefabricate your buildings. Prefabrications means two things. Actually, the first thing is that you can optimize your work, and so that's very good. Second thing is that you are very precise on site, and of course, precision means that you're not losing time and you're not losing money on the construction site. Third of all means that you potentially can produce these elements with a lower cost, with a higher precision. So increase the quality and decrease the price of it. So you see the robots in the image. This is something we'll see definitely in the future. But nowadays already the machineries that we are using to produce this amazing CLT structures are already some advanced robots. They don't have arms and stuff like that, but they are still pretty advanced pieces of equipment, of course. In the future, it's going to be possible to completely install a structure in the production facility thanks to these robots. But even before talking about other advantages, how does the CLT panel works in general? So from a technical point of view, of course, it's easy to understand why CLT is called like that. It means cross-laminated timber. And as you can see from the image, it has layers in different directions. So, and actually the most important thing is that the first layer is placed 90 degrees compared to the second one. And with 90 degrees, I mean the angle between the grain direction, between one layer and the following one. Why is this actually an advantage? One important thing is that if you compare a glulam floor, because you can use glulam as well on the side laid down, and a CLT floor, you can already see some of the main characteristics of these materials. Of course, placing elements in the two directions gives you some advantages. These advantages are, for example, that the panel is very stable dimension-wise, so you're not going to have growth perpendicular to the grain, because of course timber changes its dimension with changes of humidity, and that's one thing that you have to consider every time you design with this particular material. So apart from the stability on the dimension, the other thing is as we'll see, minimum distances that are getting lower. And third of all, last but not least, I would say, is the resistance for horizontal forces. So CLT panel has a very, very high resistance, and so it's a perfect racking, is a perfect shear wall. And we will see it how and what is a shear wall, first of all. You'll understand throughout the presentation, and why it's important to have resistance for horizontal forces. You will see it. So where does the timber come from? Of course, you see where the cuts of from a log are located. Of course, you need sometimes very long boards in order to create a master panel, because the master panel can be sometimes quite large, and therefore you need to connect all of these boards together. And you do that usually with this finger joint. You see that in the image right here, and with glue, of course. Other advantages, we were talking about this this example even before. The difference between a glulam laid on the side that you can see right here. So you can see here that all of the lamellas here are in the same direction. So this is not CLT, this is simple glulam that you can, of course, use it on the side for a floor panel. And the difference between this one, the first one, and a CLT panel that you see here on the left, the one that I'm pointing to you right now. Of course, if you just consider the resistance in one direction on the main span, you would actually have more resistance for vertical forces on the glue lamp actually. So your question might be, why then using the CLT panel? First of all, for the advantages that we've seen before, the stability and the horizontal resistance, but as well, of course, to another important, very important thing. If you use a CLT panel, it would act more as a slab, so a panel really, and it would actually work on two directions. So you would definitely have a main direction on the main span. A main direction means one main resistance, but the panel will also work on the other direction, so 90 degrees to the opposite. So you're spreading around the forces in a better way. If you use glue lamp, of course, you would have more resistance on that one direction, but you have zero resistance on the other one. So it's working as really a two-dimensional element for the resistance of it. Second of all, if you use the glue lamp as a floor construction, you have to make sure that you leave a gap between a panel and the other to make sure that you don't have troubles for the increase of dimension of the panels, because you can have that with increase of the humidity grade in the air. Another very important thing are the minimum distances. Minimum distances for timber are very, very important, and we'll do a webinar specifically for connection, and you'll see it in detail. In general, the minimum distances, though, are lower for CLT. This is because you have those grain in the two directions, and therefore you have less chances of having splitting in the timber, really, because the other layer is holding the previous one attached. So it's an automatic reinforce for each layer having those two directions. And on the other hand, you see that for the glue lamp, it's one of the issues that you might end up with if you don't calculate the minimum distance in the correct way, is ending up with the splitting of the timber. That happens if you don't leave the right minimum distance to the end grain in the glue lamp in this case. A disadvantage of the CLT, but this one can be also seen as an advantage actually, and you'll understand why, is that of course the raw material is quite of low quality raw material. Actually, having low quality raw material means that it's not planed, the boards are not planed or anything, these are just rough boards. They are just as you have them after sewing them. This means actually, though, that the material is quite inexpensive, and at the same time you can even use different grades, structural grades of timber on different layers in the CLT panel. And with this I mean you can place the lower grade timber in the central layers, so that you can save some money and not waste so much resistance in your panel. You can see here exactly what I mean. Usually these rough boards are roughly 4 meters of length, and of course the master panels can even be 12.5, 13 meters of length. So you have to connect, as we said before, with finger joints all of these panels. And one important thing is that there is a machine before the board goes into the panel itself that is cutting out all of the issues in the boards. And with issues I mean, for example, cracks, I mean the knots where the branches of the trees are. These ones are signed usually by a worker, and the machines cut away these problems automatically, where the machine sees the red lines and reconnects, of course, the board with the finger joints. This is in order to achieve a better resistance of the timber, of course. Of course, once you have all the boards ready of the right length, and as you see here, this is what I mean with master panel, the big piece of CLT from where you cut all of your little panels. Of course, you have to glue everything together. The glue is very important because it actually changes the selection of glue depending on the thickness of your CLT panel. Because if you have a very thick panel, you need a longer drying time for the glue itself, and therefore you need a different glue. If you have a very small one, the drying time can also be quite quick. You can decide if you want, if you're a producer, of course, if you want to glue your boards only on the main side of the boards, or if you want to glue together also the edges of the boards. This changes slightly also the resistance of the panel, but is mainly something that changes the look of the panel on the outside, really. So it's your choice. And another very important thing, once all the boards are laid down in the correct way, in order to dry the panel in the right way, you need to press it down with usually 1 kilonewton per meter square. And actually you have to press from all directions, so from the vertical one and from the sides as well. This is very important so that all the boards are then, you're sure that all of the boards are placed very close one to another. You don't have issues, visual issues, and also structural issues on your building. And they are left usually for something like 13 minutes or more, depending again on the thickness in this press. Of course, once the panel comes out of the press, the master panel, as we said before, you can finally do the nesting. The nesting is exactly what you see here. So you see that all of these little panels here are then placed like a big puzzle into the big master panel. And in this case, the guy doing the nesting is making sure that you have less waste possible. And this is exactly why the master panel has not a set dimension, of course. The dimension changes depending on the dimension of the little panels, floor panels and wall panels that you need to cut out of the master panel, so that again, the waste is reduced to the minimum. And this makes sense, of course, into the production. Let's see a little, pictures of the production plans. These are the finished, for example, the finished panels that are placed horizontally. Placing panels horizontally can be handy because you're maximizing your space, the space in order to have them laid down like that. Of course, you can also place them vertically. You see here a picture of the panels placed vertically on, a truck. In this case, this is again a choice of the designer. If you have panels that are, of the right dimension in order to place them horizontally on a truck, that's again one more optimized way to do it. Otherwise, you can decide to place them vertically on a truck, for instance, but you have to consider more cost of transport because you are not optimizing just as much your transport. And we'll have, by the way, another part in which we will talk about the lifting of the panels, but here you can see some of the methods that you have in order to lift up a panel, like a roof panel, a floor panel, and a wall, a simple wall. There are many ways to do it, actually. We can see here in this slide how a CLT structure works. Of course, as we said before, you always have in your panel one main direction, resistance-wise, and the other direction that still works, but it's the least resistance, has the least resistance. And of course, since it's very important then to locate and to place the panels in the right way. Of course, the resistance that timber has the greatest resistance in compression. parallel to the grain. The resistance, the compression resistance, the compression strength that you have perpendicular to the grain is actually roughly a tenth of the resistance that you have parallel to the grain. This is one important thing, because of course when you're placing and designing and then placing on side, of course, a timber wall panel, you want to have the main resistance which is vertical. In fact, in the picture here, you see that the outside layers are placed vertical. Of course, if you're placing a floor panel like that, the main resistance needs to be parallel to the main span, and that's of course one way to place it. In general, of course, this is for roof panels or for floor panels where the main resistance should be. And that's, of course, is changing also the way you're calculating your panel. Pay attention if you have a roof panel like that with a cantilever on both sides. We said that our panel has a different resistance on the two axes, and therefore you have to do two calculations in order to verify the two cantilevered parts. We already talked about the wall panels and how to place it. And it is also possible to use the big CLT panel as a beam itself. If you don't have windows in it or openings in it, you can easily use it as a wall beam, let's say. You see exactly the same structure, but we see it in real life. You see one other advantage that it's very, very clear from these pictures is that first of all, you need only 3 workers working on such a building, of such a big building apartment like the one we can see here. Why 3? Because usually one person is taking care of the lifting of the structural elements in the building site, and the other 2 are installing the elements. So actually 3 people are enough for a team of workers, even for a large structure, of course. And the second thing, of course, you can see it. Look how clean a timber structure is, and you cannot see it from the pictures, but it's actually super fast at the same time. So you don't have many people working on it, but you're very fast anyway. Just to give you some numbers, the highest building in timber that we have with a timber structure, of course, that we have here in Italy is in Rovereto. In Rovereto, it has 9 stories, and one full floor was finished completely in 1 week. So in 9 weeks, they finished the whole thing. So that's actually very stunning as a result. Another very, very nice example of a mass timber structure where CLT is used as well is the one that you can see here. I took this one as an example because this is the expansion that we had here in our headquarters of Rothoblaas, and it is in particular a very, very intriguing and unique structure because it's the only. It's actually not the only one because there are 3 of them existing in the world, but it's the biggest one existing in Europe, and it is an automatic timber warehouse with a self-supporting timber structure. You can see the construction phases of it. This one is massive because it has more than 3,500 meter cubes of glue laminate, even more CLT into it, and it was built in just 7 weeks. You'll see some other pictures of the building. You see that in this case we had 2 teams of workers working together. With the first team, again of 3 people, as you can see in the picture, where the first team was pre-assembling the big pieces of these columns connected together. So pre-assembling the whole thing. The second team, again 3 people, and you can see them here, were installing on site these pre-assembled pieces. And this is how they managed to build this very, very big construction in only 7 weeks, which is, again, stunning, having very, very low tolerances. In fact, with these methods, they were sure that the distance between a column and the other was the right one, because it was all laid out here on this structural element. And so there was no human error, and they could really do all the connections almost horizontally, being very, very, very quick. And of course, having two teams helped as well, being very fast on site. You see here some other details of the connections. All of the connections were hidden. In fact, you can see here some of the plates. This is in particular the entry of the goods. All of the connections were hidden, and this is very beautiful to see, but that was not actually the main purpose for hiding the connection like that. The main purpose was the fire resistance of the structure. Of course, if you're hiding completely a connection, you end up protecting the steel part of the protection with the timber. And we'll understand why timber has such a great characteristics and resistance to fire, even if it sounds sometimes weird, because it's a combustible material at the same time. You see some other pictures of the structure. You see how the CLT panels here were used as a bracing system for the structure. They were not the only bracing system, actually. In fact, you can see again here these 20 big CLT and glulam towers with actually some LVL elements in them as well, that were used as bracing systems for all of the other columns laid down in there. Of course, on one side, all of these columns were connected between each other and braced with those big columns. On the other side, it was not possible to connect all of these timber column together, and therefore it was harder to brace the whole system. Therefore, what was the thought of the designers of this particular structure? Of course, the thought was connecting down all of these columns with a bending moment resistant connection. And in here, you can see exactly what I mean with that. In this connection, we had two very long threaded bars on each side, of course, creating the bending moment resistance, and of course, a lot of LBS screws, little screws for plates provided by Rothoblaas for the shear resistance. Of course, another important thing, and we discussed it as well together in the first part of this presentation, is also the seismic the seismic behavior of the timber structures. Of course, the main characteristic that makes them so good in seismic areas is of course the lightweight of the material itself. So you can see that a timber structure, a structure in general, actually can resemble actually an inverted pendulum. And of course, the more mass you have on top of this inverted pendulum, the more seismic forces you would end up having. So it's very simple. If you reduce the mass of your structure, you reduce exactly at the same time the seismic forces. So this is one way to optimize your seismic resistance, of course. And this is why this test in particular that you see right here was so successful. In particular, this was a seismic test that was done in Japan with, you see a 7 stories timber structure with CLT panels. And in particular, this structure here was tested 14 times, and it survived 14 times again some of the most challenging earthquakes in the world. So it was stunning to see how good this structure survived with no damage at all to the structural members. The only damage that you could see after 14 consecutive tests were to the connections. And do you think this is because the connections were of poor quality? Not at all, actually. This is because this is exactly where you want to have your failure modes for seismic actions, because of course the steel connections and steel connectors are the one with the most ductility. But we'll see more of this, of course, when we talk about more in detail about the seismic actions and seismic resistance. This is another interesting example of a tuned mass damper, but of course we said that the way to dissipate the energy for the seismic energy is with the ductility of the connections. Actually, this is how it's done usually with the timber. Last but not least is what is a shear wall. A shear wall is the bracing system of our CLT structure, and you can see here that it can be connected in different ways. There is the standard approach here on the left, in which you have one hold down at both ends of my panel. Of course, this is the one supporting, of course, the tension forces, and you have in the central part some other fasteners, connectors, supporting the shear loads of the panel, of course. And you see how the same layout, you have the same layout throughout all the shear walls down to the foundation, really. It's very important that the shear walls are continuous to the foundation, because what they have to do is bringing down all the forces and bring it down to the foundation. There are also other approaches, actually, and you see that other approaches are placing, for example, the using hold downs that at the same time can resist the shear forces, so that you can use the same connector for all over your building. That's definitely an advantage. You can see here an example of a design of a CLT building, and it's very, very important, of course, always to to draw and to design your shear walls so that you're sure that you have enough of them on both axes. Other examples: if you have a big wall like that with openings, you can decide if you want to split it in more than one shear wall, or if you want to consider the whole thing as a single shear wall, of course. In order to do that, of course, you have to make sure that the resistance of the knit section that you have right here is enough, of course. Otherwise, you cannot do it. We said already that timber is a great material. It has some great properties because it's super resistant and super lightweight at the same time. So the ratio weight resistance is actually great, comparable to the one of steel. But it has one disadvantage. Actually, it's not a disadvantage if you consider in the right way when you design your building. It is a brittle material. So what does it mean, brittle? Brittle is the opposite of ductile. Ductile means that you can bend it in a plastic way without having a failure. A failure like that, like a breaking of the element. If you have a brittle material, this one can it can really bend in an elastic way. If you go in the forest and take a branch, you can bend it in an elastic way, but you'll see after a while, after the elastic part is finished, it will break in a brittle way. It will snap almost immediately without bending in a plastic way. So the plastic bending is very, very important to dissipate the energy, and this is why we have to rely on the connections that are made of steel, of course, to achieve that ductility, of course. It's always very important to have ductility in our structure so that you're sure that if something wrong happens, you can see it before the timber beams falls down onto your head, or you can, of course, dissipate the seismic forces if you are in a seismic area. And here is exactly what I mean with ductility in the connections, and you can see it even better here in these images of tests. You can see how the steel is bended in a plastic way, dissipating all of the energy. You always need that ductile link, which is, as we said, our connection. So always have the failure mode into the steel. So one very last but not least, again, it's important to explain the last and big advantage of the timber structures. Of course, as we said before, timber is a combustible material, but this does not mean that it doesn't, at the same time, it has a very, very good resistance to fire. How's that? Because timber is, of course, combustible, but is also a very good insulation material. And by the way, it burns in a constant and very slow way, with a charring speed, a charring rate, which is very slow. This means that it burns, it chars at a very slow rate, and most of all, it means that the internal side of the section remains intact, and it retains all of its structural properties. Of course, you can see that of course, the char layer cannot be considered anymore for the resistance of the knit section. Of course, we should remove as well a little layer, usually 7 millimeters, where usually it's heated up too much, and it's where the pyrolysis is happening. You cannot consider that little layer, but all of the rest retains all of its structural properties. Whether on the opposite side, if you do the same thing with a steel section, steel is it heats up very, very quickly, and very, very quickly loses completely all of its structural properties. So after 15 minutes roughly, the heated up steel has lost completely all of the structural resistance. It bends down like that. So very important, of course, is, as we said before, protecting also in the connections your steel pieces, your steel fasteners and connectors with the timber, actually. Thank you very much for listening, and I hope the webinar was interesting. If you have any questions, you can see my email address written down here, and don't hesitate to contact me for anything. Thank you very much.